Welcome all the students. Now we'll discuss about 10th module for this program, first year BSc Agriculture Honours for the subject Agricultural Engineering for second semester. The course code is Engineering 121 and title of the course is Soil and Water Conservation Engineering. The name of the module is Soil Loss Estimation by USLE. Some examples. I am Professor Vinod Adkari, Assistant Professor, Don Bosco College of Agriculture, Sulcorna, Kepe, Goa. The outline of the module is the estimation of soil loss due to two types of erosion, sheet and rill erosion. The USLE equation, that is universal soil loss equation, and some examples on this equation. At the end of this module, we all able to learn about the estimation of the soil loss due to sheet and rill erosion, USLE equation and examples of USLE equations. Estimation of soil loss due to two types of erosion, that is sheet and rill erosion, will be calculated by this USLE equation. Soil loss is potential threat to soil productivity and decreases nutrient and water availability available to plants. Estimation of soil losses helps to farmers in planning. Soil loss estimation by universal soil loss equation, that is USLE. This equation is originally proposed by two scientists, that is Wismer and Smith, in 1958 and then modified further in 1978. The most widely accepted method for estimating the average annual soil loss. So everywhere this equation is used to find out the average annual soil loss. It also helps in determining the adequacy of the conservation measure, different measures, either engineering or agronomical. The USLE equation is an equation prediction model for estimating long-term averages of soil erosion from sheet and rill erosion from a specified land under specified conditions. The dimensions of standard study plot was 22.13 meter in length and 9% slope in continuous fallow conditions were used for this model. USLE equation, here the erosion is a function of climate, soil, topography, land use. So the equation is A is equal to RKLSCP, where A is the average annual soil loss in tons per hectare, R is the rainfall erosivity factor or index in million joule per hectare meter per hectare hour, then K is the soil erodibility factor, LS is the topographic factor, it is a dimensionless, C is the crop management factor, it is also dimensionless, and P is the conservation practice factor or erosion control factor, it is also dimensionless. This equation gives the estimation of sheet and rill erosion only in upland areas. It does not give us erosion from other types of like stream bank or wind erosion. The different terms like rainfall erosivity index, RK, LSCP, we will see here all these terms now. What is meant by this rainfall erosivity index? It refers to the intrinsic capacity of rainfall to cause the soil erosion. It is a function of two factors, that is the kinetic energy and intensity of the rainfall. It is expressed as the product of this kinetic energy, that is Ke, into the rainfall intensity, that is I30. So the standard formula R is equal to Ke into I30. K is the kinetic energy of the storm and I30 is the maximum 30-minute rainfall intensity of that storm. The equation is based on the fact that product of this kinetic energy of the storm and 30-minute maximum rainfall intensity gives the best estimation of the soil loss given by this scientist Wismer in 1965. The 30-minute maximum rainfall intensity, that is I30 value, will be estimated from the rain gauge charts. Next factor is the soil erodibility factor given by the capital K. Erodibility is the resistance of the soil to both detachment and transportation. It can be determined through the measurement of soil loss from a standard runoff lot having size we already studied. Length is 22.13 meter and slope is 9%, which is kept fallow with periodic tillage up and down slope. In this case, Ls is equal to C is equal to P is equal to 1. Hence, the soil loss is a function of two factor only, that is R and K. From known value of R, the soil loss measurement can be done. Next is the topographic factor, that is called as LS factor. It includes the slope length, that is L, and stiffness of slope, that is S. It represents a ratio of soil loss under given conditions. So, to that, at a site with a standard slope, that is 9% slope, and length 22.13 meter. These are the standard dimension for USLE. The steeper and longer the slope, the higher the risk of soil erosion. The topographic factor, this LS factor, is given by this formula. LS is equal to L upon 22.13 raised to m into bracket 16.41 into sin square theta plus 4.58 sin theta plus 0.065. So, this formula is used to calculate LS factor. All these terms are given here. The L is slope length in meter, theta is the angle of slope in degrees, m is 0.5 for slope up to 5%, and 0.4 for slope which is ranging from 3.5 to 4.5%, and 0.3 for slope ranging from 1 to 3%, and 0.2 for the slope which is less than 1%. Next is the crop management factor. It is given by capital C. It is the ratio of soil loss from a land cropped under specified conditions to the corresponding loss from clean tilled conditions fallow land. It includes the effect of crop cover, crop sequence, tillage practices, and residue management. The value of this factor can be obtained from standard tables. The next factor is the conservation practice factor, that is P, capital P. It represents the ratio of soil loss from the land where conservation practices like contouring, strip cropping, and terracing, etc. are adopted to that where they are not. The value of P is taken as 1 where no conservation practices are there. If there are no any conservation or any forest cultivation, we will take P is equal to 1 in that equation. Standard tables are also available to obtain these values. We will see one problem on this USLE equation. Here the data is given like rainfall erosivity factor R is equal to 200, soil erosivity factor is 0.34, slope length L is given 61 meter, average steepness slope is given 8%, crop management factor C is given 0.2, it is dimensionless, hence dimension is not given. Conservation practice factor, that is P is equal to 1. So, this table will be provided during exams. So, the slope length is already given 61 meter, it is in feet 200, and slope is 8% is given. So, we will calculate LS factor from this chart. It is coming 1.41, it is highlighted here. So, we will put all this value into our standard equation. A is equal to RK LSCP. A is the average annual soil loss, RK LSCP. So, we will put all the values which is given in problem. We will come to this answer, that is 19.18 tons per hectare per year soil loss will comes from this solution. So, applications of USLE. It predicts soil loss in tons per hectare per year. Average annual soil loss will be calculated. It helps in selection of different agricultural practices. So, control factors like soil erosivity index, slope length, steepness factor, we can't control this. And control factor like crop management practices, conservation practices, that is C and P, which can be controlled by different practices like ploughing, terracing, bunding, contouring, and strip cropping. It provides recommendation on crop management practices to be used for soil conservation. Few limitations with this equation. It is a empirical equation. It predicts only average annual soil loss. It does not compute gully erosion. It is limited to only sheet and rill erosion. It does not compute sediment depositions also. So, these are the references. Thank you.